Hello viewers, in this video tutorial you are going to understand what a differential is and how it is different from derivative. So what exactly is a differential? We know that if we have a function y to be equals to a function of x, say for instance y is equal to x squared, we know that the derivative of y with respect to x tells us how y will be changing as x is changing, and this is symbolically denoted as the y dx. So the y dx is equal to 2x. Now, what if we multiply both sides of this expression or of this equation by dx? Notice that we now have dy to be equal to 2x dx. Now, you might be wondering, why will it be possible to multiply both sides by dx? Well, it is important to understand that dy dx is not a fraction, but it does work like a fraction. So dx can be multiplied by both sides. Dy stands for the differential of y, and dx stands for the differential of x. If we know how much x changes, which stands for dx, if we multiply by 2x, then we can find or tell how y is going to change. And that is the beauty of differential. Tell me how much x changes. I'm going to multiply that by 2x and tell you how y is going to change. And that is the basic idea behind differential. Now, you need to be able to find it. And for that to be possible, let's try to go over some examples. Example number 1. If y is equal to 1/3 of x to the power of 3 plus 2x minus 1, find the differential dy at x equal to 2 if dx, the differential dx, is equal to 1/4. So, to determine the differential dy, we will need to differentiate the function y. So what would be the y dx? That is the first thing you have to keep into account or consider doing. So the y dx will be 1/3 times the power, which is 3, then the variable, then you subtract 1 from the power, plus the next one, the power in this case is 1, then we have 2 times 1 times the variable, and then subtract 1 from the power, which is 1 initially. Then the derivative of the constant minus 1 becomes 0, and we need not to write that again. Now you notice that this 3 cancels the 1/3, and left over as the power of x right here is 2, as 3 minus 1 is simply 2. Then plus 2 times 1 right here gives us 2. However, x raised to the power of 0 as 1 minus 1 is 0 gives us 1. So this is our final answer. So now that we have dy dx to be equals to x squared plus 2, the goal at this point is to multiply through by dx, and therefore it means that we now have dy to be equal to x squared plus 2 multiplied by dx. Now we have to evaluate the value of dy when x is equal to 2 and dx, which is the differential of x, is equal to 1/4. So we can go ahead and substitute the corresponding values. So this simply means that at this point, dy will now be equals to x squared, which is 2 squared, plus 2, then multiplied by 1/4. And simplifying this forward, 2 squared gives us 4. When we add 2 to that, then we'll multiply by 4. And 4 plus 2 gives us 6, and we'll multiply that by 1/4. So 2 here reduces to 3, 2 here reduces to 2, and the final answer in this case is 3/2. And this is the differential dy, which means since we know how x changes by 1/4, then y will changes by 3 seconds. And that is the beauty of the differential. Example number 2. If y is equal to x to the power of 3 minus 1 second x to the power of 2 plus 4x minus 1, Find the differential dy at x equals to 1 or negative 1 if dx is 0.01. So just like before, let's find the derivative dy dx. And in this case, that gives us, since this power is 3, it can come to the form, then we have 3x squared minus 1 second times 2x to the power of 1, then plus 4. And this gives us 3x squared minus x plus 4 as the 2 cancels out. Now multiplying all through by dx, notice that we now have dy, differential dy, to be equals to 3x squared minus x plus 4, then all multiplied by dx. We have to evaluate this at x equals negative 1, dx equals 0.01. So therefore we now have 3 times negative 1 all squared minus 1 plus 4, and multiply by 0.01. Negative 1 squared gives us 1, we have 3, minus times minus gives us positive 1, and plus 4 times 0.01. And adding all these values within the parentheses, dy becomes 8 multiplied by 0.01. And therefore, the product results in 0.08. And this is how much y will change if x changes by 0.01. And that is the solution to example number 2. On to example number 3. If a function f of x equals to x squared at x equals 1, when delta x equals to 0.05, find dy and delta y. So what do you think we are going to do in this case? Well, here's what you need to know. It is important you understand that delta y is simply equals to f of x plus delta x minus f of x. So which simply means since x is equals to 1, then delta y would be equals to f of 1 plus delta of x, which is 0.05, then minus f of x, which is f of 1. Perfect. Now since f of x is equal to x squared, then definitely delta y equals to f of 1.05, as 1 plus 0.5 gives us 0.05 gives us 1.05, the minus f of 1. Now f of 1.05, we just need to square that, and that will give us 1.1025. The minus f of 1 squared is still 1. Then subtracting this in our final answer will be 0.1025, and this is delta y. Now what about dy? To determine dy, we are going to use differentials. Notice that the derivative dy dx of this function x squared is simply equals to 2x. Then multiplying all through by dx, the y, the differential y, gives us 2x multiplied by the differential x dx. Now x is given as 1, but unfortunately dx is not given. However, if delta x is given, then you need to understand that it's often equal to dx. Otherwise, the value of delta y and dy won't be close. They will be entirely different, and at the same time, these values must be approaching 0 for delta y and dy to make sense, and at the same time for them to be approximately equal. As delta x approaches 0, then the value of dy or delta y and dy gets closer and closer. I need to understand that it's often equals to dx. So therefore, delta x is equal to dx. So dy will be equals to 2x, x is 1, that's 2 times 1, multiplied by dx, which is multiplied by 0.05. That gives us 2 times 0.05. And multiplying this, we got 0.1. As you can clearly see, the values are very, very close, as the difference is just 0.0025. That's a very small number. So the value will be very, very much more closer if delta x is very, very close to 0. as delta x approaches 0 and these values approach these intercepts. And that is the difference between differentials and derivatives and how to find them. I hope you find this helpful and understandable. Thanks for watching. See you in the next video. So this is your exercise. Feel free to share a solution if you had a comment section below. If f of x is equal to x cubed plus 2x, at x equals to negative 0.5 and delta x equals to 0.01, find dy and delta y. Thank you once again. Bye for now.